All right, problem number 7, last one on the study guide for Unit 3 on quadratics. This one says calculator is required, and it's a tiny little word problem. Not much, not many words there. But it says a soccer ball is kicked out of a treehouse up into the sky and then down to the ground. Um, and it says the ball is kicked with an initial velocity of 30 feet per second upwards, and it says that the treehouse rests 25 feet off the ground. So, a little diagram. Got my tree, and I got some sort of tree house there, and that's about 25 feet off the ground. And some dude here kicking, for some reason, a soccer ball that goes boo, bloop, and hits the ground somewhere. He should probably have a head. Yeah. And we're told that the equation h of t equals negative 16t squared plus 30t plus 25 represents the height of the soccer ball t seconds after it was kicked. So if we want to answer these questions, we need to use our super awesome graphing calculator. And it says find the maximum height that the ball reaches. So first off, we should graph this. So go ahead and turn your calculator on, go to the y equals screen, and enter y equals negative 16x squared plus 30x plus 25. And now we want to graph it. So if you hit zoom 6, to get the standard graphing window, you're going to get a 10 by 10 grid that looks like this, and your graph is going to look something like jagged lines that go up like that. Which actually is okay, because we can see both of our x-intercepts. We can't see our vertex though, which is somewhere up here, and we need that vertex. So we want to adjust our window a little bit. So go to your window and give it some bigger y values. So I tried, the only difference I did was I changed the y max to be 30. And when I did that and then graphed it, it looked a little bit better. It's not the prettiest parabola in the world by any means, but I was able to see my x-intercepts and my vertex. So that's all that matters. Oh, and actually I'm a liar. 30 doesn't do it. Okay, make it 50, because it was close with 30. So make it 50, and then you can see it. And now we want to answer question A. It says the maximum height of the ball. Well, the maximum height of the ball is the maximum height of our function, whatever that y value right there is. So to find that, we go to second, hit the trace button to calculate, and go to option number 4, because we're calculating a maximum. So if you hit enter, it's going to say left bound, and just move your cursor till you're somewhere over here to the left of that point, and hit enter. Then it's going to say right bound, and then use the right arrow key to move your cursor over until you're over here somewhere, and then hit enter. And then it's going to say guess. You can just hit enter again. It tells you that the max is x equals 0.9375 ... and y equals 39.0625. And that's actually really helpful, because that tells us two of our answers. That tells us that A, the maximum height of the object, is 39.0625 feet, and it tells us that the object reaches that height at t equals 0.9375 seconds. Last question, C. We want to know how long after the ball was kicked did it hit the ground. Well, the ball hits the ground when the height is 0, and remember, this is the graph of height at specific times. So find when the height is 0, aka find that intercept right there. So again, go to second, go to trace to calculate, and this time instead of doing a maximum, you want to choose the second option, which is 0. And again, kind of similar, it says left bound, and that's just telling you to make sure that your cursor, as it moves along your graph, is somewhere to the left of that x value. So you need to be over here anywhere. Anywhere over here will work. And hit enter. And then it says, very similar to last time, it says right bound. So now you want to be anywhere down here to the right of that x value right there, which is just another way of saying your y values need to be negative. So move that cursor over until you cross the axis. And then again, tells you to guess. You can hit enter, and it's going to tell you that that point is the point x equals 2.5 and y equals 0. And again, what that means is that t equals 2.5 seconds represents the time after it was kicked, the time that it took the ball to hit the ground. So we are done.